Hello everyone, welcome to Simulator Tools available for Logicates based implementation tutorial. I'm Ajindan. I'm studying Computer Science and Technology degree program at UA University. First, let's see Logic Simulator tools. Logic Simulator is an open source tool for experimenting with and learning about logic gates. Here are some examples of Logic Simulator tools. Logisim, Cedar, Logic Friday, and Deep. Logisim Logic Simulator and its installation. Welcome to the Logisim. Logisim allows you to design and simulate digital circuits. It is intended as an educational tool to help you learn how circuits work. Logisim should run on any platform supporting Java or Java 5 or later. Logisim requires Java 5 or later. If you do not already have it on your computer, Java is available from java.sun.com. Download Logisim from Logisim's choiceperch.net page. You will three choices of which release to download. If to use Mac OS or Windows, I would recommend using the release specific to your platform. To execute the platform with the generic.jar file on Windows and Mac OS system, you will likely to able to start Logisim by double clicking the jar file. If that does not work, or if you use Linux or Solaris, you can type Java jar logisim access jar at the command line. With the macOS version, once the downloaded star.gz version is compressed, this will likely happen automatically. Just double clicking the Logisim icon to start. You may want to place the icon into the application folder. With the Windows version, just double clicking the Logisim icon. You may want to create the shortcut on the desktop and or in the start menu to make starting Logisim is easier. It's going on the Logisim simulation. This workplace. Workplace have grid lines. These lines help to easy to make a wiring connection. This menu bar. This menu are file menu, edit menu, project menu, simulate window, and help menu. This some quick icons. This simulation point. This mouse point. This text point. This input. This output, and these are three some basic gates. This not gate, this AND gate, and this OR gate. This basic simulation tools. This wiring photograph, wiring tools. This photograph gates. This photograph lecture. This arithmetic tools. This memory tools. It's input or output tools and this base tools. And here one of table. This table have circuit name or label name. We change it, and if you want modify the components, use this table. Example, this AND gate. This AND gate have five inputs. If I need to two input, I can change it to now you can. Okay. Combinational logic circuit. Combinational circuit is a circuit in which we combine the different gates in the circuit. For example, encoder, decoder, multiplexer, and demultiplexer. Some of the characteristics of combinational circuits are following. The output of combinational circuit at any instant of time depends only on the levels present at input terminals. The combinational circuit do not use any memory. The previous state of input does not have an effect on the present state of the circuit. A combinational circuit can have an n number of inputs and m number of outputs. Uh, Here, blocking diagram. Here, half adder. Half adder is a combinational circuit that performs the addition of two bits. Half-adder is the combinational logic circuit with two inputs and two outputs. The half-adder circuit is designed to add two single-bit binary number A and B. It is the basic building block for addition of two single-bit numbers. This circuit has two outputs, carry and sum. Let's move to the half-adder circuit diagram. It's going to build a half-adder circuit diagram in Logisim circuit. So Logisim simulator. First, I want to XOR gate and gate two inputs and two outputs. So I select the XOR gate, click the XOR gate and drag and drop in my working case. Then I click the AND gate, click the mouse left point and drag and drop in my working base. Then I want to do inputs. So I select the inputs, drag and drop in my working base. Click the input, drag and drop. Then I want to two outputs because some value and carry value. So I click the output, drag and drop. Then I make the wire connection between the inputs and XOR gate. So I click the wire connection point to merge the XOR gate wire connection point. Then I make the wire connection between the AND gate and XOR gate wire connection. I hope you all are now covered the circuit diagram. Then I make the wire connection between the XOR gate and output, the sum value output. Then I make the wire connection between the AND and output, the carry value. Now I create the Kagada circuit diagram, but inputs and outputs are don't have a label name. So I give the label name. First I select the one input, then I click the label box. I type the this input name. I put the A. Oh, A is here. You can see. Then I click the another input. Select the label box. Give the this label name B. Then I give the output label names. These are some value output of sum. So I select this output and select this label box. I type the display name sum. Then I click the output and click this label name. This name is carry. Now you can see this label names. I create the buffer circuit diagram. Then I check this diagram circuit. So first I select the simulation point, this point. You can select this point. Then A and B, both the low value, A is 0, B is 0. I will be give the some value is 0 and carry value is 0. Then I give the A is high value, B is low value. Some is will be give the high value 1 and carry value is 0. So A value is 0, B value is high, some value is 1, carry value is 0. Then A and B, the both the high value, some value is 0, carry value is 1. Both the one value we got, sum is 0, carry value is 1. Sequential logic circuit. The output of a sequential circuit is a function of inputs and present state of the storage element. The combinational circuit does not use any memory, but sequential circuit has memory. So output can vary based on input. This type of circuits use previous input, output, clock and a memory element. The examples of sequential logic circuit latch, flip-flop, counters and register. SR latch circuit using NOR gates. The bistable element is able to remember or store one bit of information. If the set input goes high for even a moment, the output goes high and stays high. Even after the set input returns to low, the output returns to low only when the reset input goes high. Let's move to create a SR latch circuit diagram. Now we create a SR latch circuit. The SR flip-flop latch circuit used created used NAND gate or NOR gates. Uh, Here I used to NOR gate, so I want to two NOR gates. First, I select the NOR gate, click the NOR gate, and drag and drop in my working space. Then I click the another NOR gate. So because I want two NOR gate, click, drag and drop the NOR gate in my working space. Then I want to two inputs. So I click the input, drag and drop the my working space. Then I want to do outputs. So I click the outputs, drag and drop my working base. Click the next output. Then I merge the wire connection. First I merge input and NOR gate wire connection. Then I merge the output wire connection. With the another wire connection. Now I create the SLHR gate. Then I want to give the label names. First I select the first input and click the label of label name. Uh, I give the this label name is R and select the another input and I give the this label name is S and select the output label names. This output name is Q and another output name is Q bar. Now I create the SR flip-flop latch circuit. Uh, then I check the this circuit. Uh, so first I select the simulation point, simulator point, and check it. First I set the R equal to high value. When I get the we can see Q is equal to 0, Q was equal to 1. Then I set the S equal to low value and R is equal to low value. When we can see the Q is equal to 0 and Q is equal to 1. I set the both inputs are 0 when we can see the Q is equal to 0 and Q is equal to 1 because Q is a memory element. So we can see that Q is equal to 1. Then I set the R is equal to low value, S equal to high value. When we can see the Q is equal to 1, Q is equal to 0. This is a SR LED circuit diagram. Counter. Counter is a sequential circuit. A digital circuit which is used for counting pulses is known counter. Counter is the wide application of flip-flops. It is a group of flip-flops with a clock signal applied. Counters are of two types, synchronous counters and asynchronous counter. BCD of decade counter. A binary coded decimal is a serial digital counter that counts 10 digits and it resets for every new clock input as it can go through 10 unique combinations of output. It is also called as decade counter. The above figure shows decade counter construct with JK flip-flop. The J output and K output are connected to logic 1. The clock input of every flip-flop is connected to the output of next flip-flop, except the last one. The output of the NAND gate is connected in parallel to the clear input of CLR is all the flip-flops. Let's move to create the BCD of decade counter circuit diagram. Now I am going to create a BCD decade counter. First I want to JK flip-flop. So I select the JK flip-flops, select, drag and drop it. I want to 4 JK flip-flop. So I select the JK flip-flop, select, drag and drop it. Select, drag and drop. Select, drag and drop. And early GMKR input value equal to 1. So J and K are equal to 1. So I create the input value diagram, wiring diagram. Where J and K are equal to 1. I want to one input. So I select the input, drag and drop it. This spacing is what I want to south. So change it. Okay. And then output of first JK flip-flop will be clock input the next JK flip-flop. The first JK flip-flop output is same to other next JK flip-flop clock input. So NOC same as other JK flip-flops. Okay. And this are Q, this are QR. This is output. This output is a output is a output. I want to go outputs. So I select the output, drag and drop it. Okay, and I want to one block input. So I select the block input in wiring toolbox. Mm, Select the block input, drag and drop it. Okay, this is a triple counter. Uh, this triple counter, first I check it. Uh, this check signature point. Uh, I give the one value. This is a one. I check it. This is a one. I return the values. This is a one. Zero, 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 one. First value, second value, third value, fourth value. No, zero, 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 one. And next value will be get zero, zero, one, zero. And next value zero, zero, one, one. Next value zero, zero, so one, zero, one, zero, zero. Now check it. This is the third value. This is the fourth value. I check it next to next, and then I get Erla one. Now you can see all output values are 1, the same as 15. So I get 1 to 15 value, 15. So I get 15 values, but I won't do 1 to 9 values. I don't get 10. Uh, I I get 10 when this is 1 0 1 0. This is a 10 1 0 1 0. But I don't get 10. So this one and this one is I reset the 0. So I reset this and this. So I want to one NAND gate and NOT gate. I select the NAND gate. NAND gate. This NAND gate has two 5 inputs, but I want to 2 inputs. And this spacing is what I change list and change the 2 inputs. Okay. I want to okay, select drag and drop. Okay. And inverter wiring diagrams. This okay. Okay. Now you can see the BCD counter. We can check it. First, I give the one input and check it. Now we can get 1 to 9 values. Okay, this is the BCB without the count. Decoder. Decoder is a combinational circuit that has n input lines and maximum of 2 to the power n output lines. 2 to 4 line decoder. Let 2 to 4 line decoder has two inputs. The block diagram of 2 to 4 line decoder is shown in the following figure. The truth table of 2 to 4 line decoder is shown below. Each output is having one product term, so there are four product terms in total. We can implement these four product terms by using four AND gates. The circuit diagram of 2 to 4 line decoder is shown in the following figure. Let's move to create the decoder circuit diagram. Now I create a decoder circuit diagram. So first I need to four AND gates. So I select the AND gate and drag and drop it. Select the other AND gates, drag and drop it. Select, drag and drop it. Select, drag and drop it. Okay. These AND gates have five inputs, but I want to number of two inputs, so I can change it. Now you can see two inputs. Select, change. Select, change. Okay. Then I want to do not get. So I select the not get, drag and drop it. Select, drag and drop it. Then I merge the wiring diagrams. So first I merge the wire diagram between not gate and AND gate. Okay. Now I want to number of two inputs. So first this is a 2 to 4 line decoder. So I want to two inputs. So I select the input, drag and drop it in this place, and select the another input. Select, drag and drop it. And I want to four outputs. So I select the outputs. I want to four outputs. Select, drag and drop it. Select, drag and drop it. Okay. Now I create a decoder circuit diagram. This is a 2 to 4 line decoder. First then I check the this circuit. First I select the simulation point. Then I check it. Oh, wait. I give the input and outputs outputs of name, then I check it. So first I select the first input and I want to give the this input label name. So select and change this label name. I give the this label name is a node and select the another input label name. This label name is a1. Okay, and this output label name is first select this output and select this first two. This label name is d node and select the next output. Select this label name is d1. This label name is d2 and this label name is d3. Okay, now I give the word of label names. So then I check the circuit. So I select the simulation going to first time. If a note is high, will be d1 give the one value. Otherwise, d note, d2, d3 are 0. Then a note is low value, a1 is high value, will be d2 is give the 1. Otherwise, d1, d note, d3 are 0. A note is low value, a1 is low value, d note is 1, d1, d2, d3 are 0 value. And a note is high value, a1 is high value. The a note and a1, the both are high value. We can see the d3 is 1 value, get 1. And another d1, d2, d note are 0. Okay, this is a decoder circuit diagram. This is a 2 to 4 line decoder. Okay. Encoder. An encoder is a combinational circuit that performs the reverse operation of decoder. It has maximum of 2 to the power n input lines and n output lines. It will produce a binary code equivalent to the input, which is active file. Therefore, the encoder encodes 2 to the power n input lines with n bits. It is optional to represent the enabled signal in encoders. 4 to 2 encoder. Let 4 to 2 encoder has 4 inputs. The block diagram of 4 to 2 encoder is shown the following figure. At any time, only one of these 4 inputs can be one in order to get the respective binary code at the output. The truth table of 4 to 2 line encoder is shown below. From truth table, we can write the Boolean function for each output as Q1 is equal to D2 plus D3 and Q0 is equal to D1 plus D3. We can implement the above two Boolean functions by using two input OR gates. The circuit diagram of 4 to 2 encoder is shown in the following figure. The above circuit diagram contains two OR gates. These OR gates encode the four inputs of with 2 bits. Let's move to create the encoder circuit diagram. Now I going to create a encoder circuit diagram. This encoder diagram have 4 to 2 encode. So I want to need to two OR gates. First I select the OR gate and drag and drop it and select the end OR gate, drag and drop it. This OR gate have 5 inputs, but I want to 2 inputs, so I change it. Then I want to 4 inputs, select drag and drop it. I merge the wiring connections. Then I want to two outputs. I merge the wiring connection between the OR gates and outputs. Then I want to type the input and output label names. First I select the first input and this is a D3. This is a D2. This is a D1 and select the first output. This is a Q1. Then I select another output. This is a Q2. Sorry, this is a Q0. Now I create the encoder circuit. Then I check it. First I click the simulation point. Then check it. I give the D3 sky value. We got get the Q1 is 1 and Q0 is 1. Then if D3 and D1 are low value, D2 a high value, I get the Q1 is 1, Q0 is 0. Then I give the D1 is sky value, I get the Q0 is 1. So this is a encoder circuit diagram. This is correct. Adder. An adder is a digital logic circuit in electronics that is extensively used for the addition of numbers. Adders are basically classified in two types, half adder and full adder. We already discussed about half adder. The main difference between a half adder and full adder is that the full adder has three inputs and two outputs. The first two inputs are A and B, and the third input is an input carry designed as Cin. Full adder. A full adder has three inputs and two outputs. The truth table of the full adder can be drawn with inputs A and B, Cin, outputs S and count. From the truth table, we can write the Boolean equation of the S and count. Here, similarly by using Boolean algebra and K-map, we get some equation and carry out equation. We going to create a full adder circuit diagram by using half adder circuit diagram. This is a half adder circuit diagram. We already create this diagram. Now I create the full adder circuit diagram. So I need more XOR gate, AND gate, and OR gate. So first I select the XOR gate, drag and drop it. Then select the AND gate, drag and drop it. Then select the OR gate, drag and drop it. These are have 5 number of inputs, but I want to two number of inputs. So I change this. These are two. This is a number of two inputs. This is a number of two inputs. Okay. Then full ladder have three inputs, but this this can have two inputs, but I want to move another one number of input. So I select the input, track and drop it. This is a label name I put. I give the this label name is C. Okay. Now I merge the wire connection. This is a output of some value. This is a output of carry value. Now we create the full ladder circuit diagram by using half ladder circuit diagram. So then I check the this circuit. I give the A is high value. We can see the sum is 1, carry is 0. Then B is high value, sum is 1, carry is 0. Then C is high value, we can see the sum is 1, carry is 0. Then A and B both are high value, we can see the carry is 1, sum is 0. Then A and C are both are high value, we can see the carry is 1, sum is 0. Then B and C both are high value, A is low value, we can see the sum is 0, carry is 1. Then A and B and C, A, B, C, all are high value, and Z all are high value. We see the sum is 0 and carry is, sorry, sum is 1 and carry is 1. Yes, this is correct. This full circuit diagram is correct. So then subtractor. A full subtractor is a combinational circuit that performs subtraction of two bits. One is minuend and other is subtracand, taking into account borrow of the previous adjacent lower minuend bit. This is a subtractor block diagram, and this is a subtractor truth table. This is subtractor circuit diagram. Let's move to create the subtractor circuit diagram. So I want to two XOR gate, two AND gate, one OR gate, and two NET gate, two NOT gates. So first of all, I select the XOR gate, select, drag and drop it. Then select the another XOR gate, select, drag and drop it. Then select the AND gates, select, drag and drop it. Then select another AND gate, select, drag and drop it. Then select the OR gate, select, drag and drop it. Then I want to two NOT gates. So I select the NOT gate, drag and drop it. Select another NOT gate. So like drag and drop it. Okay. Next. I want to these are have five number of inputs, but I want to number of inputs are two. So I change it. First select the gates and change the number of inputs. The two I want. I want to two inputs. So I can change. Okay. Now arrange the circuit diagram. The one input and design and the second input. These are another input. The B in with the wire connect, metal wire connections. Then I want to three inputs and two outputs. First I select the inputs, drag and drop it. Select another inputs, drag and drop it. Then I want to do output. So select output, drag and drop it. Then select another output, drag and drop it. Then I want to this input and output label names type. I give the this label names. First I select the this input and this label name is I give A. Then select the next input. This label name is B and this label name is B in. Then select the first output. This output label name is I give D. Select another output. This output label name is borrow. So I borrow. This D means different. D means different. Okay. Uh, Now we create the subtractor diagram. Then we check it. First I select the simulation point. First I give the A is high value. If A high will be D is 1, borrow is 0. Then B is high value, different is 1, borrow is 1. We can see the different is 1 and borrow is 3. So B in is high value. We can see the different value is 1, borrow is 1. The earlier high value, we can see the different is 1, borrow is 1. A and B are high value, the different is 0, borrow is 0. The both A and B are the both the high value, B in is 0, different and borrow is 0. Now we check it all, then it's correct to the subtract truth table too. So our diagram is correct. Then let's move to the diagram of subtractor in arithmetic operators. I select the subtractor, drag and drop it. Then I want the input, two input, and select the number of bits, three. Then select another input. This number of inputs are three bits. Uh, I at a number of inputs three bits. So the subtractor is a data bits is three. I change it. Then I want the output is this three bits. I merge the wire connection. This one output. Now we check it. The subtractor some values. First I select this one, this two, this. No errors. This to this. Uh, 0 1 1 2 subtract 1 0 1. I get 1 1 0 different value. Subtract and borrow is 1. Now we can try it any values. Multiplexer. Multiplexer is a combinational circuit that has maximum of 2 to the power n data inputs, n selection lines, and single output line. One of these data inputs will be connected to the output based on the values of selection lines. Since there are n selection lines, there will be 2 to the power n possible combination of zeros and ones. So each combination will select only one data input. Multiplexer is also called as MAX. A multiplexer is a circuit used to select and route any one of the several input signals to a single output. 4 to 2 multiplexer has 4 data inputs A, B, C, and D, 2 selection lines A and B, and 1 output Q. The block diagram of 4 to 1 multiplexer is shown in the following figure. The truth table of multiplexer. Let's move to create the multiplexer circuit diagram. Next, we're going to create a multiplexer circuit diagram. First, I want to two input of two NAND gates. So I select the NAND gate, drag and drop it. Then select the another NAND gate, drag and drop it. This is NAND gate that have five number of inputs, but I want to two number of inputs. First, I select the NAND gate and change the number of two inputs. Then as this. Then I want to three input of four NAND gates. So I select an NAND gate, select, drag and drop it. Select, drag and drop it. Select an NAND gate, drag and drop. Okay. These NAND gates have five number of inputs, but I want to three number of inputs. So I select the NAND gate and change the number of input three. Then I need to another NAND gate, select, drag and drop it NAND gate. This NAND gate I want to four number of inputs. So I select the NAND gate and change it four number of input. The here NAND bits are here, NAND gates are here. Then I make the wire connection first. These are selection, select inputs, and these are inputs. Input Juola now the multiplexer diagram. Okay. Then I make the output of wiring diagram. Wiring make this output. Then I want to output and inputs. First I want to go data inputs. Select, drag and drop it. Select the input, drag and drop it. Select the input, drag and drop it. Then I want to another two select inputs. Select, drag and drop it. Select, drag and drop it. Okay. Then I want to one output. This is a Q. Okay, done. Then I give these input and output label names. First I select the first input. This label name is I give the A. Then I select the second input. This input label name is B. Then I give the third input. This label name is C. This input label name is D. These are two select input. So this here select this label name is B. This select input label name is A. Okay. These are one output. This label name is I give the Q. Okay, fine. Uh, then we move to check it the circuit first. The input A is high. The output Q is high. Let's check it. First, I select the simulation point. The input A is high. The output is high. Yes, just correct. Also, our circuit diagram is correct. Then I check the another table values. The B is high and select A is high, the output high. Yes, that's correct. Then I the check it third question. The C is high, the data C is high. Select B is high, the output high. That's correct. That's output high. Okay. Then select data input is D is high. Select A and B both the high, the output is high. Yes, that's correct. So our multiplexer circuit diagram is correct. Demultiplexer. Demultiplexer is a combinational circuit that performs the reverse operation of multiplexer. It has single out input, n selection lines, and maximum of 2 to the power n outputs. The input will be connected to one of these outputs based on the values of selection lines. Since there are n selection lines, there will be 2 to the power n possible combination of zeros and ones. So each combination can select only one output. Demultiplexer is also called as demux. 1 to 4 demultiplexer has one input 1, two selection lines S1 and S0 and four outputs Y3, Y2, Y1 and Y0. The block diagram of 1 to 4 demultiplexer. Multiplexer is shown in the following figure. This is multiplexer truth table. Let's move to create a multiplexer circuit diagram. Let's we go to create a demultiplexer. I create the 1 to 4 demultiplexer. So I want to 4 AND gates. First I select the AND gate, drag and drop it. I want 4 AND gates. So select AND gate, drag and drop it. Select AND gate, drag and drop it. Okay. This AND gates have number of 5 inputs, but I want to number of 3 inputs. So I select the AND gate and change the number of inputs 3. So then I want to two NOT gates. So I select the NOT gate, drag and drop it, select, drag and drop it. Then I want to three inputs, to select the no inputs. These are one input and these are another input. And I want to there another more one input. Then I make the wiring connection. I hope you all are now demultiplexer wiring connections. Then I want to go outputs. So I select the output, drag and drop it. Go to more outputs and merge the wire connection output between the AND gate. Now I create the 1 to 4D multiplexer circuit diagram. Then I check it. Uh, 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 I first check the before I give the input and output label names. First I select this input. This input label name is I give S1, select one. Then this input label name is S2, select two. And this input is X. Then these are four inputs. So first input label name is D0. This output label name is D1. This output label name is D2. And this output label name is D3. Okay, I done. Then I check it. First I the simulation point. First exists one, the S1 and S2. The two selection point have flow value. When we see the D note is 1, then X is sky value and S1 is sky. We can see the D1 is sky and then D note, D2, D3 are low. Then X is high value, S2 is high value. When we see the D2 is high value, others are low value. When X is 1, S1 and S2 are 1. The both are 1 high value. When we see the D3 is high value, others are low value. So this is a 1 to 4 demultiplexer. Okay, guys, this is a summary of today's presentation. First, we have seen about logic gate simulator tools. Then we saw Logisim simulator and its installation. After that, I explained you how to use Logisim simulator. Then we done lot of example under the combinational logic circuit and sequential logic circuit by use Logisim simulator. Now I hope all of you get a good knowledge from this video. And thank you guys.